I'm Anil Kumar sharing with you questions from my student on trigonometry 3D problems. We are doing applications of sine law and cosine law. I'll discuss two similar questions in this particular video. The question here is question 1. Two roads intersect at an angle of 12 degrees. Two cars leave the intersection, each on a different road. One car travels at 90 kilometers per hour and the other car at 120 kilometers per hour. After 20 minutes, a police helicopter 1000 meters directly above and between the cars notes the angle of depression of the slower car is 14 degrees. What is the horizontal distance from the helicopter to the faster car? It's kind of complicated question. I like you to pause the video, read the question, understand, solve, and then look into my suggestions. Now let's try to sketch a diagram and then figure it out. So we have two roads intersecting at an angle of 12 degrees. So let's say these are the two roads which are intersecting at an angle of 12 degrees. So this angle here is given to us as 12 degrees. Two cars leave the intersection, each on a different road. One car travels at 90 kilometers per hour. So let's say this is one car traveling at the rate of 90 kilometers per hour. And the other at 120 kilometers per hour. So let's say this is faster at 120 kilometers per hour. After 20 minutes, when time t equals to 20 minutes, if I convert that to hours, it will be 20 over 60, which is 1/3 of an hour. So it says, after 20 minutes, a police helicopter 1000 meters directly above and between, somewhere in between and above the cars, notes an angle of depression of the slower car, which is this one, is 14 degrees. What is the horizontal distance of helicopter? So horizontal will be along this road to the faster car. Okay, so let's say this is the point O of the intersection where 12 degrees angle is formed. Now let us find the distance traveled by each car. Let's find distance by each car. So let's say distance for slower car, let's say S. Slower car will be, the speed is 90 kilometers per hour, so it is 90 kilometers per hour times time, which is 1/3 of an hour, right? So if you cancel the units, we get kilometers. 90 divided by 3, so it gets 30 kilometers. So let us say this distance here is 30 kilometers. Similarly, let us find the distance of the other car from this point O. So distance for faster car is 120 kilometers per hour times 1/3 of an hour, and that gives you 40 kilometers, right? So this distance, let's say up to here, is 40 kilometers. Okay. So what we get here, that the distance between the two cars is actually that much, right? So we are saying this is the slower car S and this is the faster car F. We can actually apply the cosine law. So let's say cosine law to find SF, the distance between these two cars. So this distance S to F is how much? Let's call this distance as capital D, right? So the capital D distance between the cars is, applying the cosine law, 30 square plus 40 square. I'm not writing the formula, you know it, right? Minus 2 times 30 times 40 times cos of angle between them, which is 12 degrees. This is the square of the distance, right? So let's calculate this distance. It is equal to 30 square plus 40 square minus 2 times 30 times 40 times cos of 12 degrees is equal to 152. Let me write this as 152.44, right? Now if I have to find distance, I have to really square root it, correct? So I'm saving some space here. So let me square root this answer, and square root of answer gives me 12.34. So we get this as 12.34. Let me write, okay, whatever. So the whole distance here is let's say 12.3. Is it okay? This is the total distance. Now let's look into the second condition, which is a police helicopter is 1,000 meters directly above and between the cars. So somewhere in between we have a police helicopter. Is it okay? Now from here the angle of depression is 14. So let me sketch that portion. So whenever you're into 3D kind of stuff, so let's say the helicopter is 1,000 meters and this is the road, right? This is the road, and what we have here is that the angle of depression, let me draw like this. Is it okay? So what we clearly see here is that from the car, that is this point S, slower car. So this is the helicopter here, H, and this angle here is 14 degrees, right? Is 14 degrees. That means, see, this is horizontal, this is also horizontal. So that has to be 14 degrees. Is okay? 14 degrees. So what we can do here is, somewhere here the helicopter is there, right? On the top. We can find the distance between D and, let me call this as, let's the point is T, okay? So this point is T on the ground. In that case, what is TS equal to? We are given the height is 1,000, is it okay? The height is 1,000. So clearly, we can use tan of 14 degrees, right? So let's do this part. So what we will do here, we'll use this particular triangle, and we say tan of 14 degrees is equal to opposite over adjacent, which is 1,000, divided by ST, right? S to T. That is the distance along the horizontal between the helicopter and the car, horizontal, right? So from here we get that ST distance is 1,000 divided by tan of 14 degrees. Is it okay? Now 1,000 is in meters. Okay. So in kilometers, it is going to be 1, right? So this is in meters. So we could write ST equals to 1 over tan of 14 degrees in kilometers. Is it okay? Since everything is in kilometers. So let's divide 1 by tan of 14 degrees. That gives us 4.01 kilometers. So what we notice is that the distance of T with S is 4 kilometers. Let's say round it to 4. Now, how much is the distance from the faster car? Now, since that distance is 4, so we get our answer. That is the distance from T, this point is T, right? So T to faster car is, total distance is 12.3, take away 4, right? Which gives us 8.3 kilometers. Is it okay? So that is how you can find your answer. So we can write on our answer now, and the answer is that horizontal distance from faster car is 8.3 kilometers. Correct? So that is how we can find. Now here is a test question for you based on what we have done so far. Question number 2. Now this question has been there in the test paper, similar with slight variation. The question is, two roads intersect at an angle of 34 degrees. Two cars leave the intersection, each on a different road. One car travels at 80 kilometers per hour, the other car at 100 kilometers per hour. After 2 hours, a police helicopter that is above and between the cars notes the angle of depression of slower car is 20 degrees and the straight line distance from the helicopter to the car is 100 kilometers. Straight line distance, hypotenuse in this case. Determine the height of the helicopter and its straight line distance from the faster car. Right? So I'd like you to pause the video, answer this question, and then look into my suggestions. So in question number 2, we'll follow the same strategy as we did in question number 1. Two roads intersect at 34 degrees. So let's sketch it just as we did earlier. So that is 34 degrees, this angle between the two roads. Two cars leave the intersection, each on a different road. One car travels 80 kilometers per hour. Let's say this car is traveling with 80 kilometers per hour and the other at 100. So this one is at 100 kilometers per hour. After 2 hours, how much distance will they cover? Well, after 2 hours, so let's write down. After 2 hours, the slower car, so distance for the slower car is going to be 80 times 2, which is 160 kilometers. And distance for the faster car will be 100 times 2, which is 200 kilometers, correct? So what we have here is that this would be 160 and the other side be 200, right? So we'll again form a triangle. So let's say this is 160 and the other one is 200. So that becomes the triangle. Let's call these points as P and Q. Somewhere in between there is a helicopter, right? Now first case, let's use the cosine law to find PQ. So we are given two angles, inscribed side. So whenever you have side, angle, side, you have to write cosine law. Is that okay? Perfect. So we can find PQ as equal to 160 square plus 200 square minus 2 times 160 times 200 times cos of 34 degrees, right? That is square, we'll square root later. Let's calculate this answer, which is 160 square plus 200 square minus 2 times 160 times 200 times cos of 34 degrees is equal to 12541.6, let's say. So PQ will be square root of this. So we'll do square root of our answer, which is equal to, we can round this to 112, right? 111.9, round it to 112. So this distance is 112. The horizontal distance between P and Q. Let me write this as 112 here. Is it okay? Now, let's look into the helicopter part. It says, a police helicopter that is above and between the cars notes the angle of depression of the slower car 20 degrees. So let me make this triangle now. You understand the concept. So we're talking about the slower car. And we are saying that this time the angle of depression is 20 degrees. So this is 20 degrees. So this is also 20 degrees, correct? Now it says the straight line distance from the helicopter to the car is 100. So this distance is 100 now. Hypotenuse is 100. We need to find that particular distance, right? So let's say this is helicopter horizontal base somewhere here, right? And from this base, The point P is how far. We know this angle is 20 and line of sight distance is 100. So we need to find base, cosine of 20, correct? So we'll use cos of 20 degrees is equal to pH over 100. So that means that pH, the horizontal distance, is equals to 100 cos 20 degrees, which is, let's calculate, 100 times cos of 20 degrees, it is equal to 93.96. I could write this as 94. Is it okay? So it is 94 kilometers. Now since we know this part is 94, let's say here, then the remaining will be how much? The remaining part, which is, we are calling this as our helicopter point. So H to Q will be total distance, which is 112, take away 94. So 112 take away 94 is 112, take away 12 is 100. No, 94, I'm sorry. 112 take away 94 is 18, right? So we get this distance 18. So that means this distance is 18. But what we need to find is determine the height of the helicopter and straight line distance from the faster car. So to find the height, we know this is 20 degrees. To find height, let's say height of the helicopter is h, tan of 20. Is that okay? So actually I will take it up in the next page, as this is causing problems. Okay, let's do it on this page. So what we have done so far is kind of like this. So what we have is, let's do a recap on what we have done. We found that this was 160, 2 hours distance, this is 200, and the total distance between these slower car, which is at P, faster car at Q, is 112, right? And we found that the helicopter is somewhere here, so that its distance from the slower car is 94, and therefore the distance from the faster car is 18, right? This is what we found. So let me redraw this situation. So what we have here is a triangle like this. Now I'm doing in 3D, right? So let's say the helicopter is kind of stationed here. On the left side we have slower car, and on the right side we have the faster car. So what we figure out so far is that the angle here with the slower car, which is P, this is helicopter point, this is Q, that is 94, this is 18, and the angle of elevation here is 20 degrees, which is actually the same as the 20 degrees depression angle. Now in this particular situation, let's find the height h. So height h, we know 20 over pH equals to tan of 20 degrees, correct? So height h equals to, pH is 94, right? 94 times tan of 20 degrees, since pH equals to 94 kilometers. Is it okay? That is what we calculated. So we can use the calculator, find the height. So we have 94 times tan of 20 degrees, which is 34.21. So which is 34.21. So that is the height of helicopter. So we know now the height, and we can now find, let's say this point is T for us, okay? So now we can find the straight line distance. So straight line distance to faster car is TQ, let's say, right? So TQ. So TQ will be equal to, we know the horizontal is 18, is square root of 18 square plus the height, which is 34.21 square, right? So let's do this. We'll use Pythagorean theorem now. So we have square root of 18 square plus 34.21 square, which is equal to 38.65. Right? So you can round this to whole number. So we could write this as 39 kilometers, right? So that is how we can find the straight line distance, so approximately 39 kilometers, right? Since all distances are given in whole numbers, we rounded it to whole number. So I hope the concept is clear. So what we did in this particular case was, we began with the simple scenario, two cars leaving a point at an angle of 34 degrees, found the distance between the cars after 2 hours, and helicopter we were given the straight line distance that helped us to find the distance in between from these two cars. Now from the angle of elevation we can also find, or angle of depression, which is kind of same, we can also find the height of the helicopter. So we actually found the height also, and then we found the distance from the faster car, and it worked out to be 39 kilometers, 38.6. So I hope that helps. So these 3D problems could be tricky. You may have to draw two diagrams at times, one for horizontal layout and one with the vertical layout to solve them. That is the key. And these two are very good examples. One of them can be expected in your test paper. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.